I will show you how to get the best cosmic crash course of your life. Ready to unravel the universe's grand finale? Picture this, the Big Freeze. Over billions of years, the universe expands relentlessly. Galaxies drift apart, stars flicker out, and energy becomes a distant memory. We're left with a cold, dark, and lifeless expanse. Brrr, talk about chilling. Next up, the Big Crunch. Imagine if gravity says, "Hold on, let's pull things back together." The universe could collapse into a singularity, a cosmic do-over that might just kickstart another Big Bang. It's like the universe's version of a dramatic encore. But wait, there's more. The Big Rip. Dark energy goes haywire, tearing galaxies, stars, planets, and even atoms apart. Talk about a cosmic rip in the fabric of reality. Then there's vacuum decay. Quantum mechanics might trigger a phase transition to a true vacuum, altering the laws of physics and annihilating everything at the speed of light. Poof, and we wouldn't see it coming. And let's not forget the Big Bounce. The universe might just expand, contract, and bounce back over and over in an endless cycle of cosmic rebirth. Finally, the multiverse hypotheses. Maybe our universe's end is just a gateway to a new beginning in a grand multiverse. So, how will it all end? The answer is still out there, hidden in the stars. Until then, keep looking up and wondering. The universe is full of surprises. Now, let's dive deeper into each of these fascinating theories. The Big Freeze, also known as the heat death, is a scenario where the universe continues to expand forever. As it does, galaxies will move further and further apart, making it increasingly difficult for them to interact. Stars will eventually burn out, leaving behind white dwarfs, neutron stars, and black holes. Over an incomprehensible amount of time, even these remnants will decay, leaving a universe filled with low-energy photons and elementary particles. The temperature of the universe will asymptotically approach absolute zero, making it a cold, dark, and lifeless expanse. This theory is grounded in the second law of thermodynamics, which states that entropy, or disorder, always increases. In the end, the universe will reach a state of maximum entropy, where no more work can be done, and time itself may lose its meaning. Next, we have the Big Crunch. This theory posits that the expansion of the universe will eventually halt and reverse. Gravity, the force that pulls objects together, will overcome the expansion driven by dark energy. Galaxies will begin to move closer together, and the universe will start to contract. As it does, temperatures will rise, and densities will increase. Eventually, all matter will collapse into a singularity, a point of infinite density and temperature. This singularity could potentially trigger another Big Bang, leading to a new universe. The Big Crunch is a cyclical model, suggesting that the universe goes through infinite cycles of expansion and contraction. This theory is supported by some interpretations of general relativity, but it requires that the density of the universe be greater than a critical value, which current observations suggest is not the case. The Big Rip is a more dramatic and violent end. In this scenario, dark energy, the mysterious force driving the accelerated expansion of the universe, becomes increasingly dominant. As it does, it will cause the expansion rate to increase without bound. Eventually, the repulsive force of dark energy will overcome all other forces, including gravity, electromagnetism, and even the strong nuclear force. Galaxies, stars, planets, and even atoms will be torn apart. The universe will be ripped to shreds, leaving behind a featureless, empty space. The Big Rip is based on a specific type of dark energy called phantom energy, which has a peculiar property. Its density increases as the universe expands. This leads to a runaway expansion that ultimately tears the universe apart. Vacuum decay is a more subtle and insidious end. According to quantum field theory, our universe exists in a false vacuum, a metastable state that is not the lowest possible energy state. A true vacuum, the lowest energy state, could exist, but our universe has not yet transitioned to it. However, quantum fluctuations could trigger a phase transition to the true vacuum. This transition would create a bubble of true vacuum that expands at the speed of light, annihilating everything in its path. The laws of physics as we know them would cease to exist within this bubble. Vacuum decay is a chilling prospect because it could happen at any time, and we would have no way of predicting or preventing it. The only consolation is that the probability of such an event occurring is extremely low, at least on human timescales. The Big Bounce is a more optimistic scenario. In this model, the universe undergoes a series of expansions and contractions. After a big crunch, a new Big Bang occurs, leading to a new period of expansion. This cycle repeats indefinitely, with each new universe potentially having different physical laws and constants. The Big Bounce is supported by some interpretations of quantum gravity, which suggests that the singularity at the Big Bang could be avoided. Instead, the universe would reach a minimum size and then bounce back. This model offers a way to reconcile the apparent beginning of the universe with the idea of an eternal cosmos. Finally, we have the multiverse hypotheses. This is not a single theory but a collection of ideas suggesting that our universe is just one of many. In some versions, new universes are constantly being created through processes like cosmic inflation or black hole formation. Each universe could have different physical laws and constants. The end of our universe could simply be a transition to a new universe within the multiverse. This idea is highly speculative and currently beyond the reach of experimental verification. However, it offers a tantalizing possibility that the end of our universe is not the end of everything, but just a new beginning in a grander cosmic landscape. So, how will it all end? The answer is still out there, hidden in the stars. Each of these theories offers a different vision of the future, and we may never know which one, if any, is correct. But the quest to understand the ultimate fate of the universe is a journey that drives scientific discovery and fuels our imagination. Until then, keep looking up and wondering. The universe is full of surprises, and the end may be just the beginning of something even more extraordinary.